given these two parametric equations, I would like to find the corresponding rectangular equation. I have x equals to 3 cosine theta, y equals to 4 sine theta. Oh, the theta, missing a line. And then theta is between 0 and 2 pi. I see a cosine and a sine. That reminds me one of the Pythagorean identities, sine square plus cosine square equals to 1, or cosine square plus sine square equals to 1. Then we need to isolate the sine and cosine on one side. Okay, starting from doing this, I have x over 3 equals to cosine theta, and then y over 4 equals to sine theta. And then I will state the identity. That will be sine square theta plus cosine square theta equals to 1. This one, x goes first. We can write cosine square plus sine square equals to 1. And then I will just square both sides, right? So after you square both sides, you have x squared over 9. That is a cosine square. And then you add sine square, y squared over 4. Not 4, sorry, 16. And then that is equals to 1. So the theta is gone instantly. The theta was a parameter. Now the theta is gone. This is back to a rectangular equation, and then I call this the standard equation of an ellipse. Standard equation of an ellipse. If you do not remember this, the standard equation of an ellipse, hyperbola, parabola, a circle, you have to review conic section, okay? Or you have to look it up, because this might be used very frequently. And then in that chapter where you study ellipse, they write the standard form like this, x minus h. Because there is just x squared, I will just replace that with a 0. X squared over 3 squared. And then plus y squared, I can do y minus 0 squared divided by 4 squared equals to 1. And then this one, that tells me the center of the ellipse is at 0, 0. The 2, 0 you see in the equation. And then b is equals to 3, and then a is equals to 4. A is greater than b. So that tells me this is a vertical ellipse. A vertical ellipse. Let's sketch a vertical ellipse. Vertical ellipse looks like that. I have x-axis and then a y-axis, y and then x. The center is at 0, 0, and then the a equals to 4 is you go 4 units up, and then you go 4 units down. And then the 3 means you go 3 units to the left, and then 3 units to the right. And now you sketch the ellipse. I will try my best to make the ellipse looks as... Okay, that looks a pretty good ellipse. Okay, 0, 0, 3 units top, up and down, 4 units up and down, 3 units left and right. So I just went from a parametric equation to a standard equation. My standard equation is right there. And then my standard equation is a parabola. So of course, this is from a standard equation. There is no orientation. If you want to draw the parametric curve, then you have to use a table. This table requires more work. For parametric curve, I have t, and then let's select some values from 0 to 2 pi. How about I will just do the 0? You can do a pi over 3 and pi over 6, but to save some time, I will just do a pi over 4, and then I will go to a pi over 2. So that is the first quadrant. And then the second quadrant, 3 pi over 4, and then a pi. That is the second quadrant. And then the quadrant 3, I will do a 5 pi over 4. And then I will reach to the y-axis, 3 pi over 2. This is from a unit circle. And then from 3 pi over 2, I will go to 7 pi over 4. And then I will return to the 0, which is a 2 pi. Okay, and then you have x equals to 3 times cosine theta, and then y equals to 4 times sine theta. Okay, for pi over 4, this is in root 2 over 2, unit circle. root 2 over 2, x and y, unit circle. If you don't remember anything about the unit circle, now is a time to look it up because you will need this. And then this is in quadrant 1, and then you have a 3 pi over 4, 5 pi over 4 in quadrant 3, and then 7 pi over 4 in quadrant 4. So you get the same value. The difference is the plus and the minus will change. In quadrant 2, you have negative x and positive y. Quadrant 3, negative x, negative y. Quadrant 4, positive x and negative y. This is a 3 cosine 0 that is equals to 0. And then this is a 3 times the x coordinate, root 2 over 2, which is, I will just approximate that. And then this is a 3 times a 0. They are all 3 times. So I will just write 3 first. 3 times. 2 pi, cosine of 2 pi is equals to 1, right? Cosine of 2 pi is equals to, cosine of 2 pi, yes, cosine of 2 pi is equals to 1. And then 3 pi over 4, that is negative root 2 over 2. And then pi, x is equals to negative 1. And then negative root 2 over 2. And then x equals to 0. And then root 2 over 2. I will approximate all this value. And then this is a 4 times. I will just do the 4 first. And then cosine of 2 pi. Sine of 2 pi is equals to 0. So this the first point is the first point. We have x comma y. This point is a 3 comma 0. This point is 4 times sine of 0. That one gives you a 0 comma wait, last time I didn't get this right. This is sine of 0. No, cosine 0. No. This is actually incorrect. Okay, I was doing this too fast. Cosine 0. Cosine 0 is equals to 1. So that is equals to 3. That is equals to 3. And then 4 times sine of 0. Sine of 0 is equals to 0. 4 times 0, that is a 0. So this one starts as 3 comma 0. And then we also end at 3 comma 0. Okay. And then pi over 4, I have root 2 over 2. Pi over 2, y is equals to 0. And then 3 pi over 4, y is negative root 2 over 2. Hold on, pi over 2. Okay, I'm sorry, that is a positive. That is a positive root 2 over 2. And then at pi, y is equals to 0. And then at 5 pi over 4, y is equals to negative root 2 over 2. And then 3 pi over 2, y is at negative 1. And then at 5 pi over 2, y is negative root 2 over 2. Okay. And then this is 0. I keep getting this wrong. Sine of pi over 2. Sine of pi over 2 is 1, comma 4. And then this is negative 3, comma 0. And then this is 0, negative 4. 0, negative 4. 0, negative 4. So we go from here and then right there, negative 3. And then 0, negative 4. And then we back to that point. Okay, perfect. And then this point is 2.1, comma 2.8. And then this is a negative 2.1, comma 2.8. And then this is a negative 2.1, negative 2.8. And then this is a 2.1, negative 2.8. And then you graph them, you should have the orientation. Then the orientation will be going this way. From right to left, we travel on that ellipse. Okay, let's sketch the graph. Running out of space on this page, that's fine. So we have this. Okay, I think the easiest way is we do this. This is a 3, 4, negative 3. Is that symmetrical enough? Yep. And then negative 4. So it should go this way. This is the orientation. And then for the pi over 4, okay, I'm trying to make the ellipse looks nice. And then for the pi over 4 and the 3 pi over 4, you have a point right there. And you know that it is going this way. Then that is the orientation. So this is a parametric curve. We usually call this a C, or plane curve, for this parametric equation, for the parametric equation given at the very first line. So we just use a table value, we plot all the points, and then trace the orientation. Then this is a parametric curve. You see the direction. Of course, don't forget the x and the y. And then for the rectangular equation that is in the box, then the equation of an ellipse, and then that one does not have orientation. All right, so that is the end of this problem. I will just go ahead and move on to the next video. We will start a different problem in the next video. See you there.